Okay, so today we're going to try something a little bit different. We're going to, hopefully you all have watched this video at home as part of your formative and independent practice. And we are going to work on these in class on tomorrow. So let's go over a couple of things. First of all, a literal equation. The word literal, if you look at the word literal, hopefully it'll trigger in your head something on the lines of letters. If something is literal, it means it's to the letter, which is figuratively saying word for word. So a literal equation is an equation or a formula with several letters. So in this case, variables are the letters. A formula is an equation that has a rule or is a rule. It states a rule for a relationship among quantities. Sometimes you guys have seen maybe like circumference of a circle is diameter times pi, or if you thought of area of a circle, area equals pi times r squared, radius squared. That's a formula where basically if you know the radius, you would plug it in, multiply it by itself, multiply it by 3.14, and you get the area. That's a formula or an equation that has a rule or a relationship among quantities. When you're solving a literal equation, you're not solving like a regular equation such as this. Let's say I give you 2x minus 5 equals 12 or 15. To solve it here, you're solving for x, adding 5, you get 2x equals 20. Then to get x by itself, you divide by 2 and you get x equals 10. You're undoing what's being done in reverse order. So you're solving by undoing. You perform inverse operations. Backwards. So the last thing you do is the first you undo. So let's take, for example, a literal equation that does not have a solution. The steps would be figure out what variable you're asked to solve, figure out the order of operation, parentheses, exponents, multiply, divide, left to right, add or subtract. So that is a little better. There was a typo there. And then once you figure out the order of operations that you're supposed to be performing, you work backwards. You use the inverse to undo. Let's look at this example. The largest yo-yo in the world is 32.7 feet in circumference. That's huge. That means that the distance around the whole yo-yo is 32.7 feet if you were to stretch that out into a string, the distance. The formula for the circumference of a circle is 2 times pi times the radius, or diameter times pi, because 2 radii is 1 diameter. Solve the formula for r. Okay, so if we have the formula c equals 2 pi r, and we're trying to solve for r, step 1 is to identify the variable you're solving for. So let's make it a different color. You're trying to get r by itself. And so the first thing you have to do is undo what's being done. So you may ask yourself, what's being done to r? Well, the first thing is that it's being multiplied by pi, and it's being multiplied by 2. You can also say it's being multiplied by 2 pi. It means the same thing. So to undo that, what you've got to do is divide by 2 pi. When you divide by 2 pi on the right side of the equal sign, pi divides away, divide by 2 pi, and you get r by itself, which is what you were looking to do. Radius is circumference divided by 2 pi. This is the transformed formula of c equals 2 pi r, so that now you can actually solve for r, which leads us to step B, They want to know what the radius is. Well, they told me that the circumference, which is the C, is 32.7. They want to know what is R. So if the circumference is 2 pi r, is the formula, and I just solved for r right here, I know that the radius is the circumference, which is 32.7, divided by 2 pi, where pi is about 3.14. And when you do this order of operations, you get 2 times 3.14 is 6.28, and 32.7 on your calculator, 32.7 divided by 6.28 gives you about 5.21 if you round it. So you know the radius is 5.21 feet. All right, let's look at the next question. Solve for the variable indicated. All right, they want us to solve for m. That means we're finding out what happened to m. Step 1, what did we do to m if you knew what m was? Well, order of operations says that the very first thing you would do is multiply m by 4. Sometimes it helps to write it out. So we multiply by 4. Then you minus 3n. Then you minus 3n. And you don't have to worry about the value of n because they're not asking you to solve for n. They're asking you to solve for m like mom. So in order to work backwards from here, if this was the last thing you did, that's the first thing you're going to undo. So first, you're going to add 3n to both sides of the equal sign. Remember, you cannot combine 8 and 3n. You get 4m equals 8 plus 3n, because they're not like terms. And the second thing you're going to do is divide by 4. And when you divide by 4, you do it to both sides of the equal sign. And your final answer is that m is equal to 8 plus 3n over 4. Remember, you're not getting an actual solution. You're not getting x equals 5 because you have so many variables involved. You have m and n, and you cannot solve for a variable when there's 2 of them. So you're just going to transform it, and you're going to get another equation. Alrighty, let's look at the next one. You are solving for n again. N. So here's n. Order of operations says that the first thing you would have done would have been, if you know what n is multiply by 3. That's the first thing. Then you add 6p. So that's the second thing. So to undo it, you're going to work backwards. The first thing you're going to do is undo that plus 6p. So you're going to minus 6p. And remember, here's your equal sign. So if we rewrite that problem so that we have more space, you're going to minus 6p from both sides. You cannot combine 15 and 6p because these are unlike terms. So you're just going to get 15 minus 6p equals, this cancels out, 3n. And the next step is to undo that multiplication by dividing by 3. And remember that division, now we use the fraction bar. So it's divided by 3 and divide the whole thing by 3. That's going to give you n equals 15 over 6, minus 6p divided by 3. Now you should always check to see if you can simplify even more. Okay? In this case, 15, 6, and 3 are divisible by 3. So as we will learn a little bit later on, if I divide or if I expand this out, this is the same thing as 15 over 3 minus 6p over 3. That is equal to n. And 15 divided by 3 is 5. 6 divided by 3 is 2 with the p there, equals n. So take a good look and take your time as you're looking over this, because it's important to see that what you're doing is you're actually breaking this fraction, this division, into the two parts, 15 over 3 and 6 over 3, remembering to keep the minus. Okay, let's look at the next one. You're solving for k, so ask yourselves, what would I do if I knew what k was? First, the first thing I would do is minus 2. That's the first thing I would do. And then I would divide by 5. Then you would divide by 5. And then, so the next thing to do is work backwards. Step 1 is to multiply by 5. Step 2 is going to be add 2. So let's do the multiplication by 5. Please make sure you remember that you're multiplying 5 to the entire left side and the entire right side. When you do that, the 5's divide away, you're left with k minus 2 on its own is equal to, and 5 times 11 is 55j. So now what you have done is you have undone the last thing. Then you have to change that minus 2 and you're adding it to both sides. That gives you k equal to 55j plus 2. You have solved the equation in terms of k. Okay, now let's go on to the next page. Last 3 questions before you are working on your independent practice, which we can do in class. You are solving for t. The first thing you're doing to t is you're multiplying it by this whole parentheses. You are multiplying it by r plus 4. That's the only thing you're doing to t. So to get it alone, you are going to divide by r plus 4. And you're going to divide by the whole parentheses, because that whole parentheses is an expression that is symbolic of one value. When you do that, the r plus 4's divide away, and you get t is equal to 28 over r plus 4. Now, if you were to go back to the one that we just did, when you break up the second part, you cannot break this part up because it's 28 over r plus 4. It's not two things on top that could be broken down. So look at the difference between that one that you see and this. This one, you could say r over 28 plus 4 over 28. But the one above, you can't break up the 28 into 28r over 28 plus 4. You want to leave it like this, even though at some point you would be able to break it up, but we're just going to leave it like this. And the reason that you would break it up is a little bit further math that you're not going to have to worry about. So this here is the answer. All right, now you are solving for x, but pay close attention because there's two x's. You have an x here and you have an x here. In order to solve, you have to get these x's together, but these x's are being multiplied by different quantities, so you can't combine them. So let's look to see. First, step 1 will always be get variables together. So I'm going to minus xz to bring him over here with this guy because it's currently plus. That would leave you 3x. I'm going to put the minus xz by it. Minus 2y is equal to 5. Now think to yourself, I'm trying to get x by itself. But here, there's lots of things being done to x. It's being multiplied by 3. It's being multiplied by z. And then that minus 2y is kind of keeping the x's from getting alone. So you're going to get rid of that minus 2y, and you're going to bring it to the other side of the equation by adding it. That's going to get it so that the expression on the left now only has x's. You know, the x's are only on the left side. There's no x's on this side, and nothing else. This doesn't have an x, that's why we move it over. The next thing, after you get all the x's together, is you're going to try to isolate the x. You're trying to get it alone. And the only way to do that is to think of the distributive property. Remember, when we had something like x times 3 minus z, what we did is we distributed it, and you got 3x, and you got minus zx. So now you're working backwards. You're trying to take out the x from both of these, hopefully remembering that it is basically reverse distribution. So when you take that x and divide it out, the 3 minus the z is left. And you could check your work, because if you redistribute it, you would get 3x and xz, which is this, 3x and xz. Now you're not done yet, so you're going to write equals 2y plus 5. Let's go ahead and do that in the same color ink so that it equals 2y plus 5. And now you're going to look at it and go, okay, is x alone? No, he's being multiplied by the parentheses. So to undo it, I'm going to divide by the parentheses to both sides. That leaves x alone equal to, and now you just rewrite that literal expression, just full of letters. And this is your answer. X is equal. I don't expect you to understand this one right away, so just look over it again, go backwards and look at it again, and we'll go over it again tomorrow. Okay, let's look at this one. We are solving for D. Oh, there's a D there and a D there, so we have to gather them together. So, here's my equal sign. You could minus D and bring it and becomes positive 2D. Or you can minus 3D, but you have to remember that this is positive 1, so that would give you negative 2. So let's bring that D over here. Remember, it's the same thing as 1D. We get 5C equals 3D minus 1D is 2D minus 1. Almost there. That minus 1 needs to be brought over because he is on the wrong side. We add 1. And you get 5c plus 1 is equal to 2d. Even closer. D is being multiplied by 2, so I'm going to divide it to the entire equation. Remember, whatever you do to one, you do to all. Final answer is that D is equal to 5c plus 1 divided by 2. And again, you look to see if you could break it up the way we did before, and it doesn't do anything. It doesn't simplify it further. So you just leave it like this. That is the answer. So tomorrow we're going to go through these independent practice questions. Please wait until you get to class so that you can work on them and you can ask me questions. There will also be a math space available for you to work on if you need a little bit of extra practice on this.